Welcome to Istio Service Mesh. First of all, the standard starters. Who am I? So I'm Alex van Boxel. I'm a Google developer expert for cloud. That's actually in my evening job. And in the day I work at Vente Exclusive. It's part of the Vente Privé group, a big French company. Probably a few of you know them. They're here actually. I'm there as a software architect in the data team, but I help the other groups along with Kubernetes and enter like Istio and do demonstrations and then to get them up to speed to get to the next level. So both of them combined makes me the super geek. But why are we here? Istio, so service mesh, it's something quite new. So we'll go over what it does, how it does it, and hopefully, fingers crossed, we do a bit of a live demo with a super user interface that I designed myself. Do a big disclaimer, it's version 0.2, it came out last week, and so don't use it in production. But I heard some people, oh, I want to use it in production. I wouldn't. But a bit of history. So a bit of the people moving to the cloud. How did it start? It started with typically virtual machines. I say virtual machines. A lot of you are like Google geeks, so probably you say, well, App Engine. But if you look at enterprises, they're not really comfortable on using things like App Engine and serverless yet. They used to have still used to their big boxes. So the first thing they do when they move to the cloud is go to virtual machines. So, but what typically you do in a virtual machine, it's like run big blocks of monoliths on there. It's kind of slow to start up the machines and all those things. But yeah, it's a start. People, enterprises, small companies, big companies, they move to the cloud, virtual machines, they see the benefit of spinning up new machines, a lot of scalability, dynamic control, and so things. So they start to have like a feeling, we have to divide our big monoliths into smaller blocks. And up come containers, like Docker came along. So it's actually people that were used to virtual machine. Docker is like a very small step. Well, it's still a big leap, but a very small step to start working with containers. So Docker, it's not rocket science because all the technology that is in there is based on technology that was there from the 90s, 80s, or longer even. In the 90s, yes, I'm that old. I worked on Solaris also with resource separation and those things, and that worked. But it was kind of hard to use. Docker made it really easy to use. Just one big tar file with all their files in there, and some mechanism to start that tar file on your virtual machine, running it. And it seems like virtual separation. Then, of course, when Docker arrived, people got used to the idea of containers. Then you still needed to orchestrate them over different machines. It's not really useful to have like only one machine, spin up a few Docker instances, let them communicate with each other. It gets very useful if you have like containers running over different machines. But then you have like the added complexity of having them, how do you allocate this to this machine? When a machine dies, I'll have to move to there. So Google came up with Kubernetes. There were already some concepts out there as Mesos, and also Docker is making some container orchestration systems. But actually, if you look at the market, Kubernetes is like a very big deal. Why? Because it like creates like a nice abstraction, and also different vendors are providing it. Even Microsoft and a few weeks ago, even Azure and Amazon are going to provide Kubernetes out of the box on their cloud platform, and you still can run it on premises as well. So people got used to containers, splitting up their big monoliths in smaller parts. That's kind of okay, but with that comes a lot of added complexity. Not only do they need to talk to each other, but yeah, if you read the papers with Netflix, you have to have like authentication between your containers, circuit breakers, timeouts, all those things. And once you go polyglot and let every team decide for itself what kind of framers they use. One team will work in Go, the other one will work in Python, the other one in .NET, the other one in Java. There's like a lot of boilerplate that's needed for your boundary conditions. Like you do an HTTP call to another service, okay, have to have a library that has timeout, maybe retries, yeah, please do, or exponential backoff. It could be kind of cool that a library will provide that. Also, yeah, you have it in one library. Yeah, why not in the other? Yeah, of course, if you the people in the Python team and the Go team actually have to have the same kind of feature sets. So, of course, there are a lot of libraries there that provide that for you. Still, you have to build that into your code, get it there. Maybe they're not 100% compatible with each other. So it's kind of a pain, a real pain. In the team we're working with actually 2 main languages, and we're experimenting with Go. So it's like .NET and Python. Still, you already see there's like, okay, we have like to authenticate from one service to the other. In Python, we have to implement the same kind of GWT tokens. It's kind of a pain. It's not rocket science. It's doable, but it's a pain. And like, yeah, developers in general are kind of lazy. So if it comes out of the box, why not? So what is missing? There's kind of a hint I already said. It's all actually boundary condition, living at the boundary, because you have your application, you do a call to the other one. There's where the pain is. That is where you have to implement the circuit breakers, timeout handling, retries, and so on. And also in the incoming side, there's again a boundary. What the service side implement things like circuit breakers and authentication and those things. So there's something missing. So maybe we could push that to the network itself. And actually, yes, because normally the boundary is the network. And if you have to write something in between, why not push it to the network? But yeah, networks like kind of routers and those things, or on the local host, just network paths, how do you can control that? Well, that's why Istio kind of came out. So the definition of Istio, it's like it's an open platform for connecting, managing, and securing the communication between all your microservices. So in short, but yeah, how? The thing is, there is like a trick you can do. Is like say, okay, let's pass all our network traffic not directly from part A to B. Let's put something in between, a service proxy. So that's how it does it. So it plugs in. Don't worry, I will have like boxes and diagrams showing later on. So with all the details. So and what will Istio do is like having connectivity, making resilience, reliability, secure communication, and also make all the communication visible and observable. Because it's also a big pain to see like where's all my traffic going to. So you can also implement tracing into your application code, but if you can push that to the network layer as well, why not? So before the mesh, you had like your application, border code, boundary code. You also had like some tricks, because if you have like in the network, you can say I'm whitelisting this machine to that machine just with IP on the firewalls on the network. But let's get all rid of that. So let the service mesh replace all those things. So it's not the application, it's just part of it. It's actually everything in between. A smart network. Let's show some boxes, because I've done a lot of throwing around with my hands. This will make it a bit clearer, I hope. So typically, actually, I haven't asked the question, but I hope most of you do know a bit of how Kubernetes works. Who doesn't? Or who? Oh. So, okay, Kubernetes. So it runs your Docker containers, and your services, and your small microservices in between. If you want to communicate from one service A to B in your container cluster, typically you have like 5 machines or hundreds or thousands. It even supports 4,000 machines. So if you have a few running instances of that service A, a few of your instances running B, scattered around. So you'll need to find your counterpart service B. So in Kubernetes, there is like a few ways to do that. It's or to environment variables, or preferably due to a DNS call. So container I will do a DNS call of B. Where is B? It will get an IP address within your cluster, and that is the service kube proxy. Kube proxy, you do your call to a proxy that will say, okay, I have like 10 versions of this. I'm gonna just do round robin the call to one of those instances. So every network call directly is going through a proxy. So it's kind of like already some smart networking, but on the Kubernetes level. It's only built for discoverability and load balancing between those things, between services. Because only Kubernetes knows where your instances of B live. But what changes in the mesh world? So people who are using Kubernetes for a while are very used to this concept of just you doing DNS call, and your call goes to one of your instances of B. It's kind of very straightforward. You do just like you would do like an internet call. In the Istio world, it changes a bit. In the you have your container. Kubernetes has the ability to put something next to the container. It's called a sidecar, just like the motorbikes with their sidecar next to it. Just put some stuff next to it, and it scales linear, just like your container itself. So if you have 5 instances of your container, you have 5 instances of your sidecar. So it's not meant to get your database in there and scale up with it. No, it's just to have like all kind of nice things you put on top of your container. What does Istio do? So with each container, it will add a service proxy, and that's Envoy. Go into details later, but there's like an init container that starts every time there's a new instance of your container. What does it do? It does a lot of IP table magic. IP table on Linux, it's like a way of firewalling, rerouting network calls. And what does it do? It actually says, normally if you go to this could do a call to B or C or whatever. No, what it does is like say, every network calls, they just go to Envoy magically. It's like your container doesn't know, because it's like done on the kernel level. So it just still does its call to B, but every traffic is routed to Envoy. The same for outside calls that come from the outside. It's not directly going to A, it will go to the Envoy proxy. So Envoy, it's like a proxy, it's created by Lyft, but still you have like a control plane, and that's part, there's two big parts. It's pilot and mixer. So pilot is like a platform independent part that will tell Envoy how to discover other services. It plugs into Kubernetes. So it talks to Kubernetes and says, hey, if that service wants to go to service B, it will ask where the hell are they located, and it will tell Envoy directly instead of going to that proxy that does the second hop. No, it's Envoy will know due to pilot telling it. So it's made for the service discoverability, also the load balancing, because it's the Envoy that will do the load balancing. Mixer, it's a very interesting part that makes it even smarter, because only with pilot and service relocation it already augments it with new features, but Mixer also intercepts all those traffics and sees how many calls are made, how big are they, what are the headers of your HTTP call. In this version of the 0.2, it supports HTTP, gRPC, and now just with the new version also does recognize Mongo and Redis. So it actually knows the protocols and it intercepts and gets information out of there. So if you do like a call from to the other service, everything in your mesh will at the end side also go through the Envoy. So it does two hops because it needs to check that the things that came from there are valid. Typically that's what you do in your application as well. So you write your boilerplate for your client, and here you write your boilerplate for the server. But that's now pushed completely to Istio. There's even an authentication part, but I'm not going to dive too much into there. It will make sure that the traffic over the network is still encrypted. So you can still do HTTP call plain vanilla HTTP calls to the Envoy, otherwise Envoy can't intercept it. And Envoy will make sure that it's encrypted over the wire. So typically, a mesh will look like this. All your services, they all have Envoy. Otherwise, it's not part of the Istio mesh. It has like a lot of advantages, but like if there's some service that's excluded and not part of it, there's no way that it will get in there. So there are two extra components to actually communicate with the outside world, and that's ingress and egress. Those components will make sure that there is like traffic in and out of your mesh network. Also having the advantage that you can control those things. So if you want to go do an outside call, you go to the Egress Controller. You can whitelist everything from your mesh. You can only do calls to this, and this. That's also a feature set that's available. So typically it will look like this. So you have your mesh running on Kubernetes. Since last week, it's also possible to have like extra machines, extra virtual machines next to it, making part of your mesh. But the trick is always, it's all Envoy. It's like a very, very powerful system. Envoy, so it's a high-performance proxy written in C++, and does all interception. It also recognizes all those protocols that I told you about: HTTP, gRPC, Mongo, and other will come soon. Downside is it needs to know the protocol, otherwise it can't do anything with it. Control by pilot, that will tell you where every other service is, and helped with mixer for doing quotas and so on. So the mixer is very interesting. So if you say I can do only 100 calls, this will say I already got a call, I got a call, I got a call, and mixer will then say you have like your rate is exceeded. Please open your circuit breaker. That's what mixer actually does. And outs. So let's deploy a reactor. It's some small demo app. It's actually the same app. What does it do? I do a call to an endpoint. It will do a lot of calls just to create some traffic. So it goes to A, B, and C. They all do calls to user and roles. That doesn't do anything except also tell what the version is. They're just saying I'm version 1, I'm version 1, I'm version 1, I'm version 1. Okay. So I've adapted the code for the newest version from that was out there last week. On my Twitter feed, I'll send a link to the repo, so if you want, you can play with it. There are also in the Istio manuals, there are also nice examples with a bookstore. It has like a real user interface instead of mine, but this one demonstrates generates more traffic. So kubectl. Oh. Let's hope the network gods are there. All right, that's good. We're going to deploy version 2 as well. Comes later. Okay, while this is going on, let's go to the Kubernetes Google. I'm running a Google Container Engine. Of course, this is DevFest. Let's see. This should be there. Namespace is Reactor. Okay. Let's show one of them. So with this interface, you can see which each pod, with each small part within Kubernetes, how much CPU, how much memory it's using, and also how it's being deployed and how it's described. So what did I write? First of all, I installed Istio in my cluster, just to run through the manual. It's like those different components, and also new, and also you need like an alpha cluster, so that's why I'm not running in production, that automatically changes the things you deploy. So of course, you do not care about Istio in your application, that's the whole point. You just write your applications as is, and just say, run it, deploy it to the cluster, and it will add stuff there. Actually, it's maybe better to just show it like one pod. Manage pods. So this is the thing I wrote. Review. Forgot to change the name, but this is my part. So Reactor version 3. What did Istio do? Running as a plugin in Kubernetes, just adds like this proxy. And of course, the IP magic, you don't see it in this picture, but it's really adds a component. And didn't have to do anything. I just didn't need to write this proxy or create those YAML files that the Kubernetes understand to manually know. You just do as is. Voila. So that's not that exciting. But let's go into the feature set and then work further with this example. So, what does it bring? Like, we had like a lot of theory, but let's break them up in 3 big parts. So, resilience, typically the circuit breakers, timeouts, and so on. It's something developers do really not care about. They actually get their job is to add business value, not to have like run those boilerplate. But people that manage those things like ops, and if you're in a DevOps environment, then you do care. So a circuit breaker, for example. Why is a circuit breaker interesting? It is for if you have like your service, you're talking to like MySQL database, and you know my service can handle a maximum 100 connection because it's like heavy things that it's doing. So if I go over 100, I will just overload my database, and everything will go running slower and slower and slower, and actually you will bring down the complete system. So that's why you need circuit breakers. You can say like I can handle 100 max, so that's already over the limit. But as soon as this is reached, make sure that you just don't accept anything. Because otherwise, if you accept something, you will start doing database calls. And this is actually the thing you have to say to Istio. So the reviews, it's one of the examples that is with the installation. Version 1, handle a maximum 100. So, and Istio will make sure that it doesn't go over, instead of, again, doing that with boilerplate code in your application. Operation guys really love those things. Load balancing. Kubernetes does normally load balancing for you, but Istio will bring some added values on top of this. Normally, you have like a typical load balancing is like round robin. Okay, I have 10 versions of B, first 1, then 2, then 3, then 4, then 5, then 6, and again. But it is actually known that the random is actually, for most of the services, actually better to just randomly pick one instead of load balancing. Don't ask me why, but it is so. And another kind of load balancing algorithm is to see which one of your services has like the least number of connections. It could be that you're round robining and see this one has 10 connections, test connection, 5 connections, 10, 20, and okay, let's pick the one with the least one and 5 and make a connection to this one. Istio know this due to the mixer that all collects all those information of all the services. It says, okay, and it will tell the Envoy to pick the correct service. It is initiated by the client because otherwise the proxy would do that. The client will pick then directly the network call. Retries. So for the developers, how many people do implement retries with exponential backoff into your own network? Not a lot. Although if you do like calls to your Google services, you really need to do those things. But the library does that for you. But if you do it internally, that's something that's quite overlooked a lot. So again, just put a YAML, push a YAML to the Istio network, say version 1 of the rating service, 3 attempts is okay, and just try for 2 seconds. And timeouts, again, who does really implement timeouts in their client or sets it correctly? Not a lot of people. And the thing is, it's also better to put that outside. So If you had implemented in your client, you probably would have had a fixed number, because otherwise you had to again externalize it, put it in a config file. Again, a lot of boilerplate code. If you can make Istio do that for you, it's a lot better. And if you're running in production and you see that the timeouts are just a bit too aggressively set, while the service can still handle it, you could hire that just by pushing a new version of the YAML and trying it out. Doesn't it work out? Okay, revert it without actually changing anything of your application. Then fault injection is the other big part. Also, that's not typically for operation guys or developers, but QA people will probably really love this. And if you're implementing like a chaos monkey in your microservice architecture, it's also a good tool to have. Like fault injection, just say, so this is pure for testing, don't do this in production. If you want to have like test and see how my application behaves in a laboratory condition, just inject like in 75% a 5 seconds delay, or just pick your HTTP status that you want to have like 60% of your service return. It's a very good mechanism, because typically that's something you cannot really do, and that will never be implemented in one of the libraries. That's the only thing where you can do that is on a network level. Okay, let's try this. Hopefully, yeah, we have time. So, building on top of, no, sorry, I'm gonna go into traffic management, and then I'll do the demo, because it's built on traffic management. So traffic management is like the last big part about policy, and is a really great tool. This is actually one of the most exciting parts of Istio from my standpoint, is like traffic routing or splitting. If you deploy a new version of in Kubernetes, there are some kind of ways to do canary builds. Like, okay, I have now a new version, I have 10 versions of version 1, I want to try version 2, let's put one pod in place there and see how traffic goes. Are there errors? Okay, then I'll pull it back. Are there no errors? Okay. But I find it personally kind of cumbersome. You have like your deployments, you have rollout and so on, but you do not have like a lot of control. While if you put Istio in between, you actually have like a lot more control, because you have like, yeah, it knows about those different versions, and it's aware of the network, so it can do a lot more. So, but the typical thing is you can deploy like a bunch of your new version, and then say, well, let's do traffic splitting. And say like, of course, if you do a canary build, don't do 50-50, but do like 80-20. And is something going wrong? Just put a new version of this, and version 2 is out. If you're quite okay with it, you change the weight and give more and more traffic to that new version. Still okay. So I made some nice drawings. But this is like the most exciting part, because the mixer is aware of the protocol. You can tell it to behave different depending on something it sees. And if you're in a company that does A/B testing, this is like a really great tool. If you make sure that every call has like something that makes your network aware of what kind of user it is, like a segmentation, or like employees, or they're in a test group, or they're whatever. It's up to you. It depends from business to business. But make sure that your header just has it, like always. Then you can say to Istio, okay, man, or woman, I don't know what the gender is, do something different. So you have like a test segment. Why not let your employees first go to version 2 and then roll out to the next ones. So we typically have this. If you would just let Kubernetes do all those things, it will just load balance in between. So no policies. You say, okay, first of all, let's all traffic go to version 1, but let's get the canary policy for your test segment route to 2. So that's already exciting because your test segment gets the new version of your deployment. But it's even more interesting because it's network aware. You can have like a feature that spans like multiple microservices. You can do a group canary. If your header just traverse from through B, you can do say, okay, B and C are part of the test group. You're happy with it? So just go to version 2 and just remove version 1. So first make sure that it's tested internally and then go do it. So there are some other kind of things. Egress, already told, you have like control of what's going to the outside world. Also exciting, it will kind of you can do, because you know what the network is, you can make sure that Istio does the tracing and metrics calls for you. And we're going to skip authentication because it's like the really early worlds. And you have a lot of more control if you deep dive. But those things, if you start with Istio, those are the things you can really play with in the beginning. So let's do this. So we have like my very sexy user interface that just returns the version numbers. You see, everything is like just randomly assigning, typically the Kubernetes way. 1.1, 2.2, 1.1. The upper version is the version of itself. So how do you control it? So I'm going to show you rules. 1. So what I'm going to do here is like just force everything to version 1. From Reactor, roles, A, B, C, and D. And I do it by just Istio create file rule 1 hub. Voila, hub. A glitch. That's why I say don't use it in production. And if everything is kind of okay, everything stays on version 1. Perfect. Rules, role segment. So, okay. I'm going to do a call with a header now. Sorry, damn, here it is. Okay. So I've added a header that I showed in the example. So I'm going to apply, create a new rule. Role segment test. Okay, I'll show you. It's actually the same as on the slide. 2 up. So here you have, this is the rule. You have to give it some time though. So I'm saying the extract, it's test. I've added a test header, and you see, voila, version 2 is rolling out. Due to some time limitation, I'm not going to show you just to roll everything to version 2, because you get the idea probably through here, but I'm going to just add some faults in there. So Istio create file rule, And the one with default is number 5. Okay. Got. Just give it some time. I say that like only 60% of the calls will give you 500. So if that works, it will show you like sometimes the version going away. Okay. Voila. You see, like, yeah, I don't know if it's like exactly 60% like here, but sometimes it disappears. And it's just by saying to Istio, look, that's that destination, you get some faults in there. So, the roadmap, because it is just the beginning, like basic authentication to make aware of the user. You actually already can force to make Istio aware of what the user is due to the headers. But on the roadmap, there's some basic authentication mechanism on role-based, based on a role-based system, and also like API manageability, because it's actually not aware of what the API is, of what it is good for. So as soon as you have like that, you can have like it really aware of what the API is, instead of just going to the HTTP level. Before the Q&A, out of the box, you have like, this is not part of Istio, but because Istio is like extensible, a lot of open source tools are just provided out of the box that plug into Istio. So Grafani, it works with Prometheus, that also deployed with the demo, but not part of Istio. So it is really aware of the network, how many operations there are now, requests. And per service, you really can get metrics out of there. What version there is, and you can all track that. So that is all the things that Istio provides for you. And the tracing as well. Let's see what tracing information that is. Come on. Nothing. That's a bummer. Okay, like here. This is, again, Zipkin is like tracing mechanism that just plugs into Istio. Istio just provides all those metrics to whatever framework you have. If you have like other commercial frameworks, they probably can plug in there as well. Certainly, if it's ready. I'm sure that that commercial providers will hook into Istio. So we have maybe some few minutes for some questions and answers. Does anybody have like a question? Still on. Anybody have a question?
Hi. Is there any performance problem with the proxy? Because
actually, there will probably be some overhead, but it's really very small. Actually, if you see how much passes some other system pass through proxies, it's very small, and certainly in a Kubernetes world, you actually extend it only with one hop. Because normally the kube proxy is in between, but the kube proxy is eliminated, and Envoy will do directly Envoy to Envoy communication. So it is really like 1-2 milliseconds or something like that. So it is very small.
Hi. You have the mixer component and the other one, I forgot the name.
The pilot.
Yeah. How do you handle high availability of these two components?
So for now, again, it's one of the things that are on the roadmap for high availability. It's high availability to running different pods on Kubernetes, but then they need to sync with each other. That's not now because they're concentrating on having a feature set, but on the roadmap is high availability, and that will probably have different versions of Mixer and Pilot running there.
Okay, thank you. Do you have an idea when a stable version will be available?
No,
Okay.
not at all. Not at all. I'm not part of the Istio team, so I'm following it just from far. But it's like a project that's running into the open. If you go to the website and go to the groups, there are just like special interest groups of all parts of authentication and all those things. And if you go to there and are very interested in those parts, just join one of them, and then you can have like an idea of how far along the project is. Other questions? Yeah, we have two.
Hello, what is the company behind Istio?
Okay, so the main three companies that started this, of course, Lyft, because they started the Envoy proxy. They're running it already for a long time in production. Google and IBM. So those are the three. Probably there are a few others, because like I saw an announcement of Nginx. It's now also part of the group, and that will be probably very interesting for the Ingress and Egress controllers, that you have like an Nginx, have there's some like extra control in a way that people of Nginx are used to. But it's like Kubernetes, like an open group. Kubernetes was start with Google and Red Hat as the main contributors, but there are a lot of more now. It will be going the same way.
Hi. Is the communication only in HTTP?
So
the communication between services?
No. So the four parts that it does is HTTP, gRPC, so HTTP2. Mongo is just TCP with some interesting parts. And what was the other one? Mongo and Redis, yes, Redis, and that's also a basic protocol. But Envoy needs to understand it. So those four, and it will probably extend to the most popular ones. So
all are synchronous?
Hmm?
Only synchronous communication?
Yeah, well, yeah. But if like asynchronous communication is done on an HTTP level, so you can still do async stuff like in gRPC, but it's handled by the layer in between anyway. So, okay, I think that we're finished. So, thank you all. I hope. Yeah.